and Excel Core Pure, vectors for finding perpendicular distances. The perpendicular distance from a point to a line. If we are given a point A and the equation of a line L in 2 dimensions or 3 dimensions, we may want to find the perpendicular distance from the given point A to the line and the coordinates of that point B on the line. If we're looking for the perpendicular distance from A to the line, that will also be the shortest distance from A to the line. So let's consider the steps that are needed. So here we're looking for the shortest distance from the point A, which is given, to the line defined by P and R, which are also given. So let's define a general point on the line. Let the general point on the line PR be B, for example. And we want to know the position of B from the origin to start with. To get to B from the origin, one option is to go along the position vector OR and then a multiple of the direction vector RP. So that will define a general point B on the line, which would be 1, 0, 2 plus mu times 5, 13, 3. And if we write that as a single column vector, we'd have 1 plus 5 mu, 13 mu, 2 plus 3 mu. So now we need to find the displacement vector from A to B. So that's going to be the position of B minus the position of A. The position of B we've just found, and the position of A is given in the question. So the displacement vector from A to B will be minus 2 plus 5 mu minus 1 plus 13 mu, 3 plus 3 mu. Now this is the really important bit now. We know the vector from our given point to the line, and we know the direction of our line also, and we will be the shortest distance from A to the line will be when the displacement vector from A to B dotted with the direction of the line, which we've used RP, is 0, because we get the shortest distance, the shortest vector, when it is perpendicular to the line, dotted with 5, 13, 3, and that dot product must be 0. So when we complete the dot product, we get minus 10 plus 25 mu minus 13 plus 169 mu plus 9 plus 9 mu, and it must add up to 0, and when we solve it we get the parameter is 14 over 203. Now we know the parameter, we can look for the displacement vector from A to B, and then we can find the coordinates of B if required. So there is a detailed workings of what we've been looking at so far. And just the key point there highlighted, since B is the point on the line closest to A, the displacement vector from A to B will be perpendicular to the line direction, and hence we use the scalar product. So now we know the parameter mu, we can sub that back into the vector AB. So this is the displacement vector from A to B, and if we find the magnitude of this vector, that will be the shortest perpendicular distance. And in this case it's about 3.61 to 3.62. significant figures. If we wanted to know the coordinates of B, if we wanted to know the position of B, we could do it now by finding the position of A, which is given in the question, and adding on the displacement vector AB, which we've just found. This is an alternative method which you may want to consider. In this alternative method, we find the same displacement vector from A to B, except this time we find its magnitude. Notice all three terms, when they're squared, will be positive, and what we want to do is if we look at the AB squared as a term, we get a quadratic in mu, and this will suggest that the shortest distance will be when AB squared is a minimum, and that suggests differentiation. And if we differentiate the quadratic and set it equal to 0, we get the same. Mu is 28 over 406, which is the same value, and hence we can sub mu back into our expression for AB squared and find the value of AB. In the next session, we're going to be looking at the perpendicular distance from a point to a plane.